Coders, welcome back. After so much days, we are here to solve questions. And yeah, we'll solve the next question in LeetCode 75. We are following that list and we'll see the next question. Yeah, and what? I'll take you to the screen. Give me 1 second. And yeah. So now we last time we had solved question in maximum average, like this question we had solved. Now we'll solve the next question, that is the maximum number of vowels in the substring of given length. So I'll tell you that this is the LeetCode 75 list that you will get in in problems. You will get the study plan. In study plan you will get this list LeetCode 75. It is a public. It you can access it anytime and you can solve it. I have already solved, like I have uploaded the videos where I have solved all this question. No, not all this, but yeah, for I have solved all the arrays question, two pointers question, and now I am on sliding windows. And we'll see the next question, that is the maximum number of vowels in a substring of given length. So what does the question says? The question is maximum number of vowels in a substring of given length. And question says key given a string s and integer k, return the maximum number of vowels later in any substring of x, any substring of s with length k. Vowel letters in the English are a, e, I, o, U, that we know. And what it says, key we have given a string s and integer k, and we need to return maximum number of vowel letters in any substring of s. So maximum number of vowels, the keywords I'm finding in that question, that maximum number of vowels in any substring, the substring of s with length k. Okay, the substring is basically continuous characters in the string, and that continuous characters the length of that continuous character should be k that they have given, and number of maximum vowels. Yeah, it is pretty much simple. That first thing comes in my mind ki let's take every substring and pass it to the function, and that function will return us the number of vowels in that string. But it's basically what I was saying, key let's make a function that it will return number of vowels. Let me reduce this space, number of vowels, and we'll pass, instead of passing this, like we are passing the substring, but we will pass key from the string. We are taking the substring from where to where, that will say key from L to R. Okay, and that is the substring, that from this string take this substring from L to R and count number of vowels in it and return it. Here we will, you know how to count the vowel, right? We will run a for loop where we will take a character ch, like we'll take every character, not every character, sorry, we'll run the for loop where we'll start I index is equals to L, and I should be less than equal to R, and I plus plus, and we'll check here s of I. If s of I is equals to this a, e, I, o, u, then yeah, this is the oval. So let's see ki this is s of I is equals to this, or this, like s of I means character at that point, like character at that index is either a, is either it's either a, it's either e, is either I think I copied wrong, that I should copy this only, either a, either e, either I, and either ou, that you know, I, o, u. If that character is from this 5, like if this is the oval, then we need to count it. So for that we need to maintain one counter, that is, you can say ki count is equals to 0, and if it is, then count plus plus, and after all that return that count. This is what coming in my mind. But do you really think this is like L and R, that uh, this is the function which return the number of vowels, and that we call here, let me write it for you. L is equals to 0 and R is equals to k minus 1. Why I'm taking k minus 1? Because let's say we want 3. Let's take an example. Yes, let's say ki yes has 5 size. Yes size is 5, and for that we will take 0 and k is equals to 3. For that we'll take 0 1 2. This is the, I mean, these were the indices in that string which will have the size of k, that the substring will have the 3 sides basically. So I am taking k minus 1 for that only. Let's say ki it is k is equals to 3. I am taking L is equals to 0, so R should be equals to k minus 1. That's what all I wanted to say. I should not take the L is equals to 0 and R is equals to 3. I should take L is equals to 0, R is equals to 2. So for that, R is equals to k minus 1 basically. I hope you understood why I took the R is equals to k minus 1. And then we'll see ki how we can call this function number of vowels. And yeah, what I want ki I want maximum. So my result, maximum result, max result is equals to, let's say, 0, that I don't have any substring where substring of length came where I can find vowels. It's basically mean that, let's say ki there is a string which do not have vowels in that string. So whatever the length, that is whatever the k size, it won't be there. If there is no vowel, then count always will be 0, and that's why the minimum answer will be the 0 only. Then find that, then we'll take the length of that string, that yes dot size, and while my right pointer, that is R, is less than n, what we'll do ki we'll take the count, that count is equals to, we'll call this function. I think we can pass its reference, cause every time why will create in like we'll create the copy of that string, that it will waste of memory. So pass its we'll do the pass by reference instead of pass by copy. And yeah, we are passing here res, and we are storing it res is equals to maximum of count and maximum of result, and will then l plus plus r plus plus, that will shift to the next thing, that is here. For this example, this is the example, and for this example, if l is at here, k is equal to 3, so l will be here, and my r will be at c. And when I will take the ABC, then I need to take BCI. So for that I need to shift L and R both by 1, and that's why it says key sliding window. That window size will be the same, that is K. Though it is, I'm taking you up like two pointer approach, but that in that two pointer approach, the right pointer and left pointer's difference will be always K. In sliding window, in sliding that's the sliding window. If the right pointer and left pointer difference is maintained throughout the problem, so throughout the question, then it means ki that trick is sliding window basically. So we are solving this, and we are solving this using the sliding window, and we'll return the answer, that is my maximum result will get returned. And if I run it, then it is accepted for these test cases, but if I submit it, then it will throw me TLE error. Why? Because let's see why I'm saying this. This is taking big of your time, right? For this is also taking big of your time. Like every time I'm saying ki go, like here, go to this ABC, calculate. calculate the number of vowels in it. Then go to BCI, calculate the number of vowels. Then go CII, calculate. Every time it will start from the start, that it will start from the left to the right. Though we are just shifting one character ahead and just dropping last character, then it should take the last character only, and the character that we are including in that string substring. So we just need to check the two character only instead of checking all. So that's why that whatever I have told now, that we will implement. And in this like in this solution I have implemented the thing that is taking too much time. That not the too much, it will take the big of n square time that we don't want. We want to reduce the time. So what we'll do here, ki yeah, we just call this once, and let's say ki here I'm calling it from L to R. That is my initial answer, that I'm taking it as a maximum result. And what I will do, ki while my R is less than n, whatever I'm including it in, or if when I take the R, I'll increase the R, I'll increase the L, because now for that window the number of vowels have been calculated. So we'll go to the next character and we'll see how many vowels are there now. So for that, what we will do here, key this is we took this right, and now what we'll do, key let's say that count is count. Let me store it in that count, that this is the count. And what I will do here, key if I'm I I went to the next index, right? For my right pointer is went to the next index. My left pointer is also shifted to the next index. Now calculate that I have to calculate the number of vowels in new string now. So for that, what I have to do here, key I have to check if my yes at L minus 1 is, that I have to check this again. If yes at L minus 1 was the vowel, then if I have shifted to the next thing, that it is EL, I am at EL, but I have dropped EL, that previous EL, that was the EL minus 1, then I have to check if whatever I have dropped, that was the vowel or not. If the dropped character was the vowel, then I have to reduce my count. Otherwise, I don't have to do anything, because I never did anything when it wasn't vowel. So if I don't have to do anything when it wasn't vowel. At the same time, yeah, while counting, if I'm checking if it is vowel, then while dropping also I will check it if it is vowel or not. And also for the same, for the R, I have included the new character R. So I will check the R here, and as I'm including it, I'm not excluding it. If the next character is vowel, then count should be increased, and my maximum result will be maximum of maximum result and the count. And after all that, we will increase the L and we will increase the R. That will shift to the next character, and we'll run it, and then we'll see it is accepted. Then submit it. Yeah, it is accepted, and his runtime is less and memory we took is less. I don't know why his runtime is okay. Don't focus on that. But let's see what the time complexity for this now. For this, it is the big of k only, and cause what is do it goes here and it will just traverse the string, and the difference between r and l is here k. So I'm taking is big of k, and for these all the things is big of k minus n minus k, cause already we have done from 0 to k, so it is a big of k minus n minus k. Overall average time complexity for all these, like all this solution, will be big of n only, that in single pass we have solved this question. And let's see the what is the space complexity. Do we have used extra space here? No, we don't have used any extra space, but just we have used the lr count. So we'll say ki it is a constant that is big of one space complexity that we have used. And yeah, we have solved the question, that is the maximum number of vowels in substring of given length. And now you have understood how we can solve it using the sliding window. And if you don't understand it, watch it again. That's what I can say now. And yeah, so bye.